Okay, this set of videos is going to focus on the formulas for electricity. Now, I'm going to talk about them generally just to introduce the idea. In an electric circuit, you have four parts. You've got a conductor, a source of electricity, a load, and a switch, something to control it. So for our formulas, we have to look at what's going on in a circuit. And we've got something called current. Current is how many electrons are flowing by a certain point at a certain time. So if I have a current in amperes, it tells me that this many electrons is flowing by. When the electrons flow, they can gain energy. So we have something called potential difference, which some people call voltage. Over here, we have a potential rise. The electrons are in here, are traveling through here, and they increase the amount of energy they have. They go through the circuit, and over here, we have what's called a potential drop. That is voltage. The electrons lose their energy, they come back to the battery and gain energy. We have something else too which we call resistance. Resistance is how difficult it is for the electricity to flow in the circuit. For instance, in a light bulb here, when the electricity goes through the tiny little wire in the light bulb, it has a lot of resistance, so the wire heats up and gives off a lot of energy in the form of light. There is resistance in the wire, and there is resistance in the cell. But I might be interested in what's the resistance of this piece of wire to make this light bulb work. There's something else we need to talk about, which is power. Power is how fast you use energy. So for instance, a 60-watt bulb, that's the units of power as watts, a 60-watt bulb uses 60 joules of energy every second. And a 100-watt bulb would use 100 joules every second. So we have to have formulas that relate all of these things together. And these are pretty much the standard formulas. I've written them in this triangle form, which some people find really useful because then they can solve for, if I'm using this triangle, Q and I and T, Q is equal to I times T, I is equal to Q over T, T is equal to Q divided by I. So we have a lot of formulas, so some people like to memorize them this way. Some of them we don't normally write this way. For instance, Q equals NE, we generally write it that way and not this way. But if you use it as this triangle, then that might help you solve for the formula. Another one here that we don't generally write in this form is this one. R is rho times L over A, which is resistance, and power, I squared R, and cost of electricity is rate times energy. So the next few videos are going to be pretty short and quick. I'm going to go through each one of these explaining what the variables are and how to use them. So then you only have to watch the videos that are relevant to your topics. Okay, let's get started.